Alright, this is EOC review part 1. So this is a question that says we got point PQ and it's got some values listed for it and solve for x. Right. So first thing we do is it doesn't have a picture, so we draw a picture. And so we have line segment PQ with the midpoint M. So we have P, Q, and M. And PM is 3x minus 1. And if this is the midpoint, that means that these two line segments are congruent. That's the definition of a midpoint, which means this is 3x minus 1. So that means PQ equals 3x minus 1 plus 3x minus 1. Because PQ equals PM plus MQ. Right, you could also say that it equals 2 times PM. Either way, you get PQ equals 6x minus 2. Right? And you also know that they also gave us that PQ equals 5x plus 3. So this whole line segment equals 5x plus 3. When we know that PQ also equals 6x minus 2. So you can set up the equation that PQ equals PQ, right? Or you can say that PQ equals PM plus MQ, which equals 6x minus 2, which equals 5x plus 3. And then solving for x, you get x equals 5. Moving on. Okay, now we have two lines that intersect at point P. Doesn't give us anything else. We have two lines intersecting at point P. That's all. And this is the vertical angles equal these two things. X plus 13 and 2x minus 7. Remember, when lines come together, two sets of angles are made. You have vertical angles, which are congruent. Vertical angles are congruent. So these are vertical angles, and these are vertical angles. Right? The other sets of angles are the linear pairs, which are supplementary. So these are linear pairs, this is a linear pair, this is a linear pair, and this is a linear pair, and those are all supplementary. But we have, these are congruent. Now we don't have any points to make a generic equation like we did up here, a primary equation like we did right here. This is the primary equation, but we don't really need to. This is pretty easy just to make a pretty simple substitution equation in here. So we can go x plus 13, equals 2x minus 7, 2x minus 7. So solving for this is going to be x equals 20. So if we take an x equals 20, we can drop x equals 20 into here and into here. We know that this is going to be equal to 33 degrees, and this will be equal to 40 minus 7, which is equal to 33 degrees as well. 33 degrees. That's how you know you did your algebra correctly. Okay. Now the next one we have is this pentagon. Not only is it a pentagon, it is a regular pentagon. Okay, and that is important. Whether it's a regular pentagon or it is a regular decagon, or it is a regular hexagon, or a regular whatever-agon, right? It means two things. One, it means that the sides have, well, just say, the sides are congruent. 2, and the interior angles are congruent, right? Two things, right? You know, if it's a triangle, it's an equilateral triangle, right? If it's a square, if it's a quadrilateral, it's a square, right? Here, it's a regular pentagon, meaning that all these sides here are congruent and all these angles are congruent, right? But I don't need all that stuff to prove that what triangles are congruent inside of here. I only need two sides here and two sides here, and then this angle and this angle. And because of that, I can say that this triangle, this triangle are congruent because of side, angle, side. Oh, I'm sorry. That's right. Side, angle, side. Because of that reason. So those two triangles, triangle DEA is congruent to triangle ABC because of side, angle, side congruence. Moving on. Okay, so here is a four transversals. Okay, we have transversal A and B, transversal B, we have transversal A, we have transversal, I'm running out of colors already, transversal C, that really popped, doesn't it? And then we have transversal, I didn't use orange yet, transversal D. Okay, and these guys are parallel, and these C is parallel to D, and A is parallel to B. Okay, so things you need to remember about transversals. Right, three angles that are unique, or four angles unique to transversals. Right, you have alternate. Okay, alternate. Now, alternate means it's opposite the transversals. The two angles that you're comparing to are opposite whatever transversal you're talking about. Okay, alternate. In an alternate world, there is interior and exterior. Now, that is relative to the parallel lines. Okay. Interior means it's inside the parallel lines, and exterior means it's outside the parallel lines, right? These are alternate interior angles. And then you have consecutive angles. I'm sorry, that's not right. Corresponding angles. Now, they're not identified as alternate interior or exterior because they can't be either one of those, right? So let me show you why. Right, so if I have an alternate exterior angle, like the two here, that means that this one and this one are congruent. Oh, by the way, these are congruent. Okay, so alternate means that they're on the opposite side of this transversal B, right? And that they are exterior, which means that they are on the outside of these parallel lines. Right, so these are alternate exterior angles. So this green one here are alternate exterior angles. Right, if I were to say these orange ones here, these are alternate interior angles, right, because they're on the opposite side of this transversal, and they're on the inside of the parallel lines. Okay, if I were to use this blue one here, and let me go with this one here, right? Let me go with this one. This one and this one, this blue one, these are corresponding angles, right? They're on the same side of the transversal, and one's on the outside and one's on the inside of the parallel line. So it can't be it's neither nor of those, okay? They're all congruent, right? This one here, then we have another set of angles that belong to a transversal, and this is called a consecutive angle, And you can have interior or exterior of these. Sometimes these are called same side interior and exterior. Exterior, right? And let me use green. No, I already used green for this one. Let me use pink, okay? And so if I were to say this one and this one, these are consecutive. Now they're not in a row, right? But these are consecutive exterior angles because these are supplementary. And if I made another parallel line, it would be consecutive, be right in a row with that next one, right? And if I made, like, here's another one, if I went here and here, these pink ones here, these are consecutive interior angles. They're supplementary. They're right in a row, right? They're the same side supplementary angles. They're consecutive interior angles, and they're supplementary. They add 180 degrees if I add them up. Okay, one's acute and one's obtuse. Okay, so there's lots of different ways that they're going to ask you this stuff, right? Oh, and by the way, you also have on here your vertical and linear pairs at each one of these intersections. You can go this way, you can go this way to get from 1 to 2, right? Multiple ways to get that they're going to say, you know, this angle is congruent to this angle, is, you know, congruent to that angle, right? And it's all going to be because of transitive or because of you know, any angles that are congruent supplements, you know. Anything like if this is a supplement to this and this is supplementary to this, then these must be congruent, right? That's the congruent supplements, right? So if this is congruent to this and this is congruent to this, then these must be congruent. That's the transitive property. So you have to understand these relationships. People identify what is congruent to what and what is supplementary to what because of these reasons, right? So they're going to be drop down. This is probably going to be a drop down, and this will probably be a drop down. These angles are congruent because these angles are to this, and these angles are supplementary because these angles are to this. That's why I suspect probably C. Okay. Here I have a rectangle, so that I know that these rectangles have equal or congruent sides, and I know that these are all 90 degrees, right? And this is saying something about some hypotenuse leg, all right? So what is the hypotenuse? Is something is the hypotenuse, all right? So AC is the hypotenuse, okay? And rectangles are congruent, okay? Which means some line segments are congruent. So it could be either one of these. BC is congruent to AD, or AB is congruent to CD, right? It depends on what the drop down is. So it could be AB is congruent to CD, right? Or it could be BC is congruent to AD, depending on what the drop down is. Okay, so just make sure you're identifying what is congruent to what. Okay, so here is another one. This one's pretty kind of cool, right? So we have, let's dissect what it's asking, right? So it says that break this into two statements. Angle G, or line segment GH, angle segment GH is a mid-segment of this triangle. All right, so line segment GH is a mid-segment of, D, triangle DEF. DEF. That means that D and DG and EF are congruent, and EH and HF are congruent, and that G and that GHF is like half the size of DEF, and they're similar triangles, right? So this is 2 times HF, and this is 2 times GF. DF is 2 times GF, and it tells me that this is 1.5, right? So if these are all 2 times this, then this must be, DF must be 2 times GH. So if that's the case, that DE is 2 times GH, so this must be 3.0, okay? So that's that part, and then it tells me that DE here is the mid-segment of ABC. All right, so let me go make an orange one. So ABC is a triangle in itself, and DE is mid-segment of this triangle, meaning that this DE is mid-segment of all these, right? So this is twice this line segment, and this is twice this line segment, and this is twice this line segment. So I have a little triangle in here. I have this little triangle in here, DADE, right? So I have this little triangle, which is similar to ABC, right? So if AB is twice as long as AD, and AC is twice as long as AE, then I know that BC is twice as long as DE, meaning that BC, which is what I'm trying to solve for, is 6. So that is how I figure that one out. All right, moving on. Okay, so now I'm given a parallelogram, and it's called WXYZ. I'm going to draw that best I can. Displace that a little. And do this best I can. Do that best I can. Perfect. Okay. And I'm going to call that W, X, Y, and Z. Now I have something to work with. Now WX is 2x plus 15. Now YZ is 4x minus 21. And I know that XY is x plus 27. Right? And I got to determine the length of ZW. All right, well, what do I know about a parallelogram? I know that the opposite line segments are congruent in a parallelogram. So I can write a general equation, a primary equation of WX equals, I can just say the length of, get rid of that, length of equals ZY. And I can drop in some stuff. 2x plus 15 equals 4x minus 21. So 2 comes over here, makes that 2x, plus 21 comes over here, it makes that 36, so x equals 18. Okay, so now that that equals 18, I can drop that 18 into that equation, making that equals 18 plus 27, that equals 45. So if that equals 45, then this is going to equal 45. So that is how I figure that one out. Okay, moving on to this one here. Okay, this is number 8. Okay, so I have similar polygons. Okay, I have a prime. I'm gonna call that one green. I don't have a purple. I wish I did. Okay, and then I have a pink for my not prime. So something I need to remember about similar and congruencies, both similar and congruent angles in both those shapes, in both those situations, the angles are equal. Okay, line segments are proportional. Okay, line segments are proportional. I guess it'd just be like x over y. Make that x over y. X over y. Okay, so if I knew the measure of angle A was to 103, what's that? Or A prime is 103. Measure of angle A, which is my, So this is green. So this is green. Green is my primes, and my pinks are my not primes. Not primes. So my green, it doesn't matter because my A primes, measure of angle A equals 103. And if measure of angle D, as my not prime, measure of angle D is 97, then the prime other angle has measure of 97 is D prime. Okay, so here we go. You might have to figure out this ratio here. So this is how you do that. Right, this means that BC of my not prime is 1, and B prime C prime is 3. That is what this means. Right, is 1 over 3. This is my B prime over my C prime. And I got to solve for x. Okay, and my C prime value is 5.1, and my not prime value is 2x plus 1.5. So I'm going to set up an equation here with a neutral color, right? And my pink, which is my not prime, goes on top, right? So that's going to be 1 over 3, right? 1 over 3, because it's my prime over not prime, or my not prime over prime, and my not prime goes on top, so it's going to be 2x plus 1.5, and my not prime is, sorry, my prime is 5.1. Now I have to cross multiply to solve for x. So I'll do that by put my equal sign, and this is going to be, my one side is going to be 5.1 because 1 times 5.1 is 5.1. My other side is going to be 6x times positive 3 times 1.5. So that's going to be 4.5. Solving for x, got to bring that over. That's going to be 0.6 equals 6x. So x is going to be 0.1. So that is how you solve for that. All right. So here we go. We have a tulips. We have tulips planted on this garden. This is 10 foot long here. 10 foot long. And what is the general equation for a for a trapezoid? We'll call this the top. Call this the bottom. Oh, you can't see what I'm doing. Okay, call this the top. Call that the bottom. And this is 10 foot long. This is the mid segment. Remember, my general equation for this scenario is my top part plus my bottom part. These are all parallel, remember, right? Equals 2 times my mid segment, right? Or this is, remember, this is just the average of these two lengths, right? Another way, just algebraically rearrange it. So I don't have any like points to make a general equation, so I'm just going to drop in my x values and my 10, right? So it's going to be x plus 4 equals 2 times 10 feet. All right, so it's going to be 2x plus 4 equals 20 feet. 2x equals 16 feet. X equals 8 feet. All right, so if I drop that in, this is going to be 8. This is going to be 8 plus 4, which is 12 feet. 12, that's not right. Yeah, 12 feet. So 8 plus 12 is 20. Divided by 2 is 10 feet. All right, so that's right. Okay, so how many do I need to have in parallel? All right, so let's see if I have 1 foot, 1 foot equals 12 inches, and then I have 3 feet. Over 3 foot per each. second. Work on this. Okay, so it's asking me, I want to have a tulip planted 3 inches apart. So I have, let's see, 12 inches. I need to figure out, so 12 inches per foot. And I have, if I have 8 plus 12 plus 10, that's going to be 20 feet times 20 feet. So that's going to give me inches, and then I have a tulip every 3 inches. 3 inches per tulip. All right, so it's going to be the number of tulips. Okay, so because they're telling me that I want along the parallel sides of the garden, right? So how many parallel sides of the garden do I have? I have that parallel side, and that parallel side. So that's 8 plus 12 is 20, plus 10 is, the parallel sides, that's 20 feet. Yeah, so 8 plus 12 is 20 feet. All right, so 12 inches in a foot. I got 1 tulip every 3 inches, right? And then 20 feet that I got to cover. So that's going to be 12 times 20 equals 240 divided by 3. That's going to be 80 tulips. That's awesome. Okay, so the minimum number of bags that I gotta get, there's there's 80 tulips that I need, and then there's 25, there's one bag has 25 tulips, so 80 divided by 25 is 3.2, so I need 4 bags. Because I can't get 3.2 bags. So that's how you do that one. Okay, moving on to this one. I'm gonna pause this for a second. Use the restroom. All right, so this one is saying, hey, we have an artist, we're making canvas stuff, wants to make a logo according to what is the mailing cost and all that stuff. All right, what is the maximum length of the postcard? It falls in the dimensions. Okay, so the first one we have 4.6 inches high and long. So 6 inches long, that's the length. Okay, so we got to take 6 inches long, and the canvas is 36 inches long. Okay, so we have to do 36 inches divided by 6, right? And it's going to be equal to 6. Okay, 6 inches. Okay, that's the maximum size if it's going to be per to the scale. Okay, and then the other one's going to be 24 inches high, 24 by 6, right? So that scale is going to have to be 4 inches. Okay, so that's that one. All right, so the maximum is going to be 6. All right, so part B is what is the maximum width. All right, so it's going to be the same thing. All right, so if we wanted to do maximum width, it's still going to be 24. Right, 24 using 24 now. All right, so 24 divided by our 6.125. 6.125. That's going to be 6.125. So 24 divided by 6.125, and that equals approximately like 3.9-ish. Okay, and then we're going to be using 36. 36, if you want to do that way, 36 divided by, what are we using? 3.98? What do we get? 3.918. Because the 3.918 is going to be maximum size. 3.918. 3.918. 3.918. That's approximately 9.18, right? So it's going to be 6.125. Or so yeah, our biggest one we can do it is going to be 6.125 inches, right? So that's going to be, so we're going to do our, so this is the widest we can go, and this is the, well, that's the longest we can go, and that's the widest we can go. Okay, so that's how you do that one. All right, number 11, right there. Okay, so number 11 is we have two congruent triangles, and we're gonna go. Let's go ahead and mark it up. We have A and D. A and D are congruent. That's the single arc. We have C and F. C and F is the double arc. And then we have B, or that's a double arc, yep. And then we have A and C. A and C is, so that's going to be the triple arc because it would be opposite of this triple angle. And D and F, which is opposite of E, so that would be the triple angle too. So that is the triple line segment. Okay, determine if they're congruent. Well, we have angle, side, angle, angle, side, angle. So yes, they are. Yes, they're congruent because of angle, side, angle. Okay, so now we got to figure out what EF is. Right. So EF is this one, and it's opposite of the single line. Go over here, look at the single line, and we don't have anything to compare it to. So we got to solve for x, it looks like. Okay, so we look at what do we have for x on this one and this one. What's the relationship? Well, this is opposite of the double arc, and so is this opposite the double arc. Because these are opposite of D and A, which are congruent, we can deduce that their opposite line segments are congruent. So this would be 2 and this would be 2, and we can say that AB is congruent to ED, because congruent parts of congruent triangles are congruent. CP, CT, C. Right, so now you can say that 5x minus 2 equals 2x plus 7. This is going to go over here and be 3x, and then this will be over here to become equals 9, so x equals 3. Drop that x equals 3 into here. That makes that 12x, or 12 plus 5 equals 17. So that's the length of EF. All right. Whew. All right, so I left some time for this one, and we have a couple line segments here that I would like to talk about, or like not line segments, but triangles. We have the pink triangle. I'll color it in as pink. Pink triangle. And then we have a green highlighter. Let's see, green highlighter. I have an orange highlighter, that'll do. And I have an orange highlighter, an orange triangle. It'll be this entire thing. The entire thing is orange. And these are similar triangles. I know they're similar, one, because they tell me in the drawing that they're similar, or in the givens that they're similar. And let's see, ABC is the orange one, and ADE is the pink one. Is the pink one. I got to figure out what AC is. Got to figure out what AC is. Okay. So I got to set up proportionality. They don't give me DE. They don't give me BC, so I'm left with this proportion and this proportion compared to this proportion and this proportion. Okay, so I'm going to call these sides over here, this and that, I'll call this this leg. I'm going to call this one over here that leg. And you'll see why in a second. That makes sense. Okay, but let me go ahead and solve for some stuff first in terms of x. All right, so I know that AE is 5. I know that EC is 4x plus 3, but EC is nothing to me. It's just a portion of AC. So AC, do AC down here. AC equals AE, which is pink, AE plus EC. So that equals, you really can't differentiate that very well, can you? But it's okay. So this equals, this is 5 plus 4x plus 3, and that's going to equal 4x plus 8. And then AD, or AB, equals AD plus DB, and that is going to equal 4. I wish you could see that a little better. It's okay. Plus 5x minus 3 plus 5x, plus 5x minus 3. And let's see, that's going to be equal to 5x plus 1. So I got AB or AC in terms of x, and I have AB in terms of x. So now I can set up a proportion that will help me do some stuff. So when I'm setting up a proportion, I have one thing equal to another thing. Fractions. Oh, I should make that green. So I can neutral colors equals some other neutral colors. Okay, yeah, that'll work. Okay, and then I'm gonna do this leg, that leg compared to this leg in this column this way, and then I'm gonna do the orange triangle, the big one, to the pink one, to the pink one, to the pink triangle, to the pink triangle. I could say ABC to DDE, but I'm just gonna do orange to pink just to make it obvious. Okay, so my pink triangle, that leg for the pink triangle is 4, and then this leg for the pink triangle is 5. Okay, and then for my orange triangle, that leg for the orange triangle is 5x minus 3, and this leg for the orange triangle, oh no, that's not right. I made a mistake. That's the whole reason I did that leg. That leg is AB, and AB is 5x plus 1. 5x plus 1. Oops, almost made that mistake. Then this leg is AC, which is 4x plus 8. 4x plus 8. All right, so now I got some stuff that I can solve for x for. All right, so I'm going to go ahead and change this all to green, because everybody knows when you mix pink and orange, you get green. All right, so you get 16x plus 32. That's going to equal 25x plus 5. That's what happens when you cross multiply, right? Okay, so now I'm going to solve for x. So this over this side, this is going to go over here, and that's going to be equal to 9x, and that's going to be equal to 27. So x is going to be equal to 3. Okay, so now that I have x equals 3, I can plug that into here, right? So I can say that 4x, therefore 4 times 3, I should make that 4 times 3 plus 8 equals 20. Equals 20. So that is my length. That is my length for there. And I can also put it up here too. And I can say 4 times 3, right, which is That's going to be 12 plus 5 equals 15, and 15 plus 5, yeah, that whole thing equals 20 as well. So that's how that whole thing works. So I hope that this helped you out. And if you have any questions, please let me know.